This lesson is on linear inequalities. It's chapter 1, section 7 in your book. If you guys would please turn to page 131 and get your notebooks ready, we will start this lesson. So an inequality is going to be a math statement that involves these symbols that you guys have been acquainted with and familiar with for years. Less than, greater than, less than, equal to, greater than, equal to. Solutions to statements involving these inequality symbols don't just have a single or a couple of answers, they're going to have large intervals of answers. So one of the things that we're going to start getting used to in this lesson, a little bit different from the past, are how to indicate those intervals with brackets and parentheses. We're going to talk about them being bounded and unbounded. Bounded means there is a beginning and an end to it. Unbounded means that there isn't. So those are a few of the things that we will investigate with this video. So writing our interval answers, the less than and greater than do not include the digit itself. So if you were going to put interval notation on, you're going to use those rounded parentheses in that interval answer. The less than, equal to, greater than, equal to do include the numbers, so the hard brackets are going to be the symbols that you choose. Intervals involving digits starting and stopping are called bounded. If you have infinity or negative infinity, those are going to be called unbounded. Kind of makes sense. So here's a few examples of things that you might come across or things that you might write in the future. If you saw the interval right here with the hard bracket and the -1 and the +3, that would indicate to you with the hard bracket that -1 is part of the solution. It goes through 3, which is the top end of the solutions. So this is probably how you've been most used to seeing those kinds of statements written in the past. Okay, it's called a bounded interval. It has a beginning number and an ending number, and then it would be everything that falls in between. The second example that I put up here has kind of a combination of the brackets. So 2 is included. 8 isn't technically, but everything running up to the 8 is. So again, it has that stopping and starting point. Okay, so in interval notation, it's going to look like this with the parenthesis, which would look like this with the less than, equal to, and the less than statements in it. The third one up on the board here, -infinity to 8. Means there is no end to the bottom of this interval. It's going to trickle off into -infinity, and then it will go up as high as, but not including the 8. So you can see it written both ways there, interval notation as well as with the inequality symbols. When we start solving here in a little bit, there's one main rule with solving and working with inequalities that you have to remember. Many times when you're going through your solution steps, you're going to end up multiplying or dividing by a -1. If you do that during your solution steps, you have to turn around the inequality symbol. I think that rule will sound familiar to you. You've used it for years, but it's an easily forgotten one. All right, so here's an example of an inequality that would need to be solved. You go through the same process essentially as solving equations. You're going to group up your variables on one side, constants to the other side, and finish solving just like always. Just be watchful for if you end up having to multiply or divide by a negative. All right, so I'm going to move the x's to the left. I'm going to move the 3 to the right. And the last thing to do is divide by 5. Now, I am dividing, but I'm dividing by a positive number, so do not swing around the symbol. So my solution is x is less than or equal to 2. In interval notation, things that are less than 2 go on forever. So the bottom of my solution is -infinity. 2 is the top end, and it is included. So this would be the interval notation for that solution. Sometimes we have to graph them on a number line as well. If we needed to do that, this text also used these brackety things rather than the open and closed dots. So an example of a number line that you might see in this book for this solution, it would simply have that hard bracket, not a filled in dot at the 2, and then the shading would go off to the left. This one is called a double inequality. You might hear it called a compound inequality, possibly. But it's still going to technically follow those same solving steps. It's just that whatever you do to isolate your variable, you need to do it to the left and to the right of that center expression. So for example, if I was going to isolate my variable, I need to get rid of that 7. Well, I need to do that to all sides, not just one side now. You'd have to do it to the right as well as to the left because both of them have symbols separating them from our variable term. So -6 down here, 2x in the center, and a 4 up top. I need x alone yet, so I'm going to be dividing off that 2. I need to do it to the left as well as to the right of my expression. So -3 is less than x is less than 2. Interval notation. They're both less than signs. So I have 2 soft parentheses. There's my interval notation. On a number line, I'm going to have a soft parenthesis at -3, also here at 2, and my solutions for x would fall in between. Absolute value inequalities. Now there are a couple of you that had questions with absolute values with equations. It's kind of the same attack that you're going to have when it's an inequality as well. So make sure that you have some of these steps down. Absolute value, of course, means the distance from 0. There are 2 sides of 0. You're going to have a distance to the left of 0 as well as a distance to the right. You're going to have 2 cases to solve. So what do I do? First, isolate the absolute value part. Get it alone. Number 2, solve the situation you see. Also, set up the situation that is negative of the one that you saw and do your solution steps all over again. Now, not only will you change the one side to negative, but you're also going to swing around your inequality. It's probably easier to understand seeing me practice it. So let's do one of these together. This one's actually number 55 from your textbook. It's found on page 137. So the ones that are near and around this one, the examples would be similar too. First step, I need to isolate my absolute value. This 2 needs to go. So I'm going to first add 2 to both sides. So now I need to, with my absolute value being isolated, I need to consider 2 situations. This one, and also this one. Change the sign of the right-hand side as well as the inequality symbol. Now just go ahead and solve. In this one, my next solution step has me dividing by a negative digit. Don't forget to turn around your inequality. Come over to your next situation, solve. Divide away your -2. Turn the inequality symbol. So x is going to be greater than 4, but less than 5. So all of our solutions are going to fall between 4 and 5, not including the 4 and the 5. All right, so this is another topic that's in this section, finding an interval on the number line for which a radicand or a square root is non-negative. I pulled this one from the assignment. It's number 75 in there. It says if given the square root of x minus 5, find the interval where x is non-negative. All right, well, if I want x to be non-negative, it means I want it to be positive. So I want it to be greater than or equal to 0. Okay, you guys know from our past sections that to get rid of that radicand or that square root symbol, I'm going to square both sides. Well, the square of 0 is still 0. Move the 5. I need digits that are going to be greater than or equal to 5. In interval notation, the lowest it can be is a 5. It can include the 5, so use the hard bracket. And then it can trickle on forever, so it can go up as high as infinity. Since infinity has no end, use the rounded bracket. All right, so your assignment practice problems, take a look at the ones that are on pages 137 to 139. Read the directions, make sure you understand what they're asking you to solve and that you can then go therefore and solve them. Come back to class with some questions if you have them. That's all I have.